isomers, they have same molecular formula, right? But they are differ to each other due to the presence of different functional groups. Organic molecules which have same molecular formula but they have different functional groups, right? Such organic molecules are known as functional group isomers, and this phenomena is known as functional group isomerism, right? Let's see the examples to understand this concept. For example, if we have a molecule having the molecular formula C3H6O, a molecule C3H6O, this is the molecular formula. Now students, will see how many structures are possible. The first structure which is possible is CH3, C double bond O, CH3. This molecule, the name of this molecule is acetone. This is acetone. Right students? Now the second molecule which is possible is CH3, CH2, C double bond O, H. This molecule is known as propanol, or its common name is propionaldehyde. These are the two molecules. Now here you can notice, the students, in this molecule count the number of carbon atoms: 1, 2, 3, that is C3. Count the number of hydrogen atoms: 3 hydrogen plus 3 hydrogen, 6 hydrogen atoms. And how many oxygen atom? 1, right? So this molecule has the same molecular formula, that is C3H6O, right? But here, what is the functional group here, students? Here we know very well, if we have alkyl radical on either side of carbonyl group, this group is known as carbonyl group. If on either side of carbonyl group, if you have alkyl radical, then the functional group is known as ketone. So this molecule is ketone, right students? Now here in this molecule you can notice, identify the functional group. Dear students, we know very well, if we with carbonyl carbon, on one side if we have hydrogen atom, and on other side if we have alkyl group or hydrogen atom, then the functional group is aldehyde, right? Whatever their names, acetone or propionaldehyde, you identify the functional group. One compound is ketone, another is aldehyde. Now in aldehyde, count the number of carbon atoms: 1, 2, 3. C3, 3 carbon. How many hydrogen? 3 plus 2, 5 plus 1, 6 hydrogen. And how many oxygen? 1, right? So this molecule, which is aldehyde, also has the same molecular formula, right? Both these molecules have same molecular formulas, but they have different functional groups, right? So that's why they are functional group isomers of each other, while this phenomena is known as functional group isomerism. Let's see one more example to understand the concept of functional group isomerism. For example, if we have a molecule having the formula C2H4O2, C2H4O2, this is the molecular formula. Dear students, now we will see how many structures are possible for this molecular formula. The first structure which is possible for this molecular formula is CH3, C double bond O, OH, right students? And the second structure which is possible for this molecular formula will be C double bond O. On one side we have hydrogen, while on other side we have this group. right? The name of this molecule is acetic acid. While this molecule is methyl formate. Methyl formate. Now in these molecules, in the first molecule, count the number of carbon atoms. 1, 2. We have 2 carbon atoms. Hydrogen 3 plus 1, 4. And how many oxygen? 1, 2. 2 oxygen. So this molecule has the molecular formula C2H4O2. Right? Now identify the functional group which is present here. Dear students, we will write the functional group for this molecule. Here you can notice we have C double bond O, OH, and here we have R, right? What is the name of this functional group? This is carboxylic group. Carboxylic, okay? This is carboxylic group, and this is carboxylic acid. Carboxylic acid functional group here. Now in this molecule, count the number of carbon atoms. How many carbon? 1, 2, right? We have 2 carbon atom. Hydrogen 3 plus 1, 4. We have 4 hydrogen. And how many oxygen? We have 2 oxygen atom, O2. It means this molecule also have the molecular formula C2H4O2, right? Now identify what is the name of this molecule. What is this molecule, students? Here you can notice this is a molecule. On one side, if we have hydrogen atom, while on other side we have this group OR, right? This molecule is known as this is the functional group of ester. This is ester molecule, right? Now here one molecule is carboxylic acid, another molecule is ester, but they have same molecular formula. Molecular formula is same, but structural formula is different due to the presence of different functional groups. So this type of isomerism is known as functional group isomerism, right? And these different structures, they are functional group isomers of each other. I hope this is clear, students. Now let's try to study the next type of isomerism, number 4, that is metamerism. Metamerism. Now what is metamerism? It is a type of isomerism which is due to the unequal distribution of carbon atoms on either side of the functional group. Unequal distribution of carbon atoms on either side of functional group. We can say metamerism is due to the unequal distribution of carbon atoms on either side of functional group. Right, students? Another important thing, members belong to the same, all the metamers, right? They belongs to the same homologous series. Metamers belongs to same family or same homologous series. Homologous series, right, students? Now let's see some examples to understand metamerism. Suppose if we have a molecule having the molecular formula C5H10O, the first example, C5H10O. Now students, try to write their structural formulas, right? The first structural formula will be CH3, C double bond O, CH2, CH2, CH3. One molecule, right students? One molecule. It is 1, 2, 3, 4, 5. The name of this molecule is 2-pentanone. 2-pentanone. Now the second structure which is possible for this molecule is CH3, CH2, C double bond O, CH2, CH3. Right? Now count the number of carbon atoms. 1, 2, 3 or 1, 2, 3. You can do the numbering from either side. 1, 2, 3. Carbonyl group would come at same position. 4, 5. Right? The name of this molecule, it is ketonic functional group. So this is 3-pentanone. Right students? Now the third structure is also possible for this molecule. Third structure is also possible. How can we make the third structure? C double bond O. If on one side we make methyl group, while on other side CH, CH3, and we make one branch. Right? So if we do the numbering, 1, 2, 3, 4. Right students? So the name of this molecule will be 3-methyl 2-butanone. 3-methyl-2-butanone. So 3 structures are possible for this molecule. Right students? You can notice all the members are ketone. All these 3 are metamers. Right? It means they have same molecular formula. All these 3 compounds, they have molecular formula C5H10O. Right? What is the difference in all these 3 molecules? They have, the nature of chain is different on either side of functional group. What is functional group here? A carbonyl group is a functional group here. You can notice this is the functional group. The distribution of carbon atom is different on either side of functional group. Right? One thing. Another thing, all the 3 compounds, they belongs to ketone family. So this type of isomerism is known as metamerism. Right? To understand the concept, let's see one more example. Let's see a molecule which is made up of 4 carbon atoms. The formula will be C4H10O. This is the molecule. Let's see how many structures are possible. Right? Let's see the first structure. Structure will be CH3, CH2, O, CH2, CH3. The second structure, CH3, O, CH2, CH2, CH3. Right students? A third structure is also possible for this molecule. What should be the third structure students? Try to make CH3, O, CH2, CH, CH3, CH3. This is the third structure. Dear students, we know very well all the three compounds are ether. What is the ether functional group? If alkyl groups are attached on either side of oxygen atom, then the name of functional group is ether. Right? This is ether functional group. On either side of oxygen we have alkyl group. Right? All the three compounds belongs to ether family. What is the difference in all the three compounds? They have unequal distribution of carbon atoms on either side of functional group. Right? The name of this molecule is, this is ethyl. A radical made up of two carbon atoms is known as ethyl. This is also ethyl. So how many ethyl? 2 ethyl. Its name can be written as diethyl ether. Right, students? Now this is methyl and this is propyl. Dear students, what is the nature of this propyl? It is a straight chain, so it is N-propyl. The name of molecule will be methyl N-propyl. Methyl N-propyl ether. Right? Now let's see the third one. On one side of oxygen we have methyl, right? On other side we have 1, 2, 3 propyl. Right, students?